All right, so now we are leaving the factoring topic and we are going to start working with the quadratic formula. Before we start doing that, we want to look at a bit about square roots, all right, and how they pertain to the part of the quadratic formula that's called the discriminant. It's been a little while since we did square roots, so we're going to go ahead and talk about that real quick. So remember when we have a square root, all right, like say square root of 4, okay? We know the square root of 4 is the same thing as saying the square root of 2 times 2, which means the square root of 4 is 2. And we've talked about this before. And so what we're looking for square roots is we're looking for two identical numbers that can multiply and give me what's under the radical, which is 4 in this case. In the case for 4, I could also say, okay, the square root of 4 is actually equal to multiplying two negatives together, which also gives me negative 2. Okay, so the square root of 4 can be both positive 2 and negative 2 because a negative times a negative gives me a positive under the radical. And so that's totally a legitimate answer. And so for square roots, and in the quadratic formula, you'll actually see that when we have something like the square root of 4, you actually have two answers. You have negative 2 and 2. You may also see this written as plus or minus 2. So for each square root, we're going to actually have a positive and a negative version, which is something we haven't really talked about a lot. Okay, so when we go ahead and look at square roots like square root of 9, we're going to go ahead and assume that its roots are 3 and negative 3 or plus or minus 3. Okay, so let's go ahead and simplify some roots here. Now, this is something we also haven't talked about. These are not perfect squares. And so let's look at how we go ahead and simplify roots. And I'm going to take the square root of 8 first. The square root of 8, if I want to break the 8 down into factors, which we did with factoring, I have 4 times 2. Right? Because many times using the quadratic formula, we do not get perfect roots. All right? Or we would just factor it and be easier. Okay, so then I could say this is also equal to the square root of 4 times the square root of 2 and break it up. I'm totally allowed to do that. All right? So the square root of 4 we know from the front is plus or minus 2. But the square root of 2 here, we can't do anything with that, okay? And so we're just going to go ahead and write it out right behind it. So because we don't have a calculator, we would just go ahead and say that our x-intercepts, or where our graph crosses, is going to be at plus or minus 2, okay? So our roots here are that. Let's look at the square root of 48. All right. I'm going to go ahead and break it down. It doesn't matter how you break it down. You may see something different than me, but I see a 4 times 12. All right. And that's not perfect, but I also see something else in particular. I know that I can also rewrite this just because I have a 12. I have a 4. And 12 is 4 times 3. And what we're looking for when we actually do square roots is we're looking for perfect pairs. And I have a pair right there. So in this, it would be plus or minus 4 square root of 3. All right. Let's go ahead and look at 150. Now, if it was, normal, you could go at any other way. You could do 15 and 10, but neither one of those are perfect squares. And what I'm really trying to see if I can find a perfect square really quick. All right, so I also know 150 is 25 because quarters. How many quarters make up $1.50? Well, 4 quarters make up $1. and then 2 more give me 50 cents. So this is 25 times 6. So I could say this is plus or minus 5 for the 25 is perfect root. Remember, you could break it up. Oops, sorry about that. And so it'd be 5 square root of 6. So plus or minus 5 square root of 6. Now, as far as the discriminant of the quadratic formula, what we are looking at is the part of the quadratic formula that's the plus or minus the square root of stuff. In this case, it's b squared minus 4ac, where those a, b, and c are coming directly from some sort of quadratic equation, right? And now you know where the plus or minus came from. It came from the fact that we actually can have a positive version and a negative version. What we also want to explore with the discriminant is a lot of times when we do the quadratic formula, we do it all at one time. This is actually sometimes not a good thing. If we go ahead and do this square root part first, it'll tell us a lot of things. If the square root is a positive number, okay, this means we're going to have 2 real solutions. If the square root ends up being 0, we're going to have 1 real solution. All right. And if underneath the square root is a negative number, all right, and we haven't really dealt with it, well, we know negatives under the square root are not real or do not exist, and we're going to say these are 2 non-real solutions. All right. And graphically, it's going to look like this. If I have a positive discriminant, graphically, what's going to happen is I'm going to have some sort of quadratic graph, which is a U-shape or a parabola. And that U-shape or parabola, no matter which way it's heading, it's going to go ahead and hit my x-axis 2 times. And if it actually physically hits my x-axis, this is my 2 real solutions. And you're not going to be asked to graph these, so nobody be all crazy and upset. All right? If I have a 0 under the radical, what that means is my parabola is only hitting my x-axis at one point, which is 0. Okay, so this is my 1 real solution. My vertex or of my parabola, or my point of my parabola, or my highest point in this case of my parabola, is at the origin. The last situation where we have 2 non-real solutions, graphically what this looks like is I have a parabola, and it starts in, like, let's say, quadrant 1 going up. It's never going to touch my x-axis at all. All right, so graphically, it's already above the x-axis and it's continuing to go up. And this is where you get non-real solutions. All that really means is that graph is never going to touch the x-axis at all. Doesn't mean the graph does not exist. Right? That just means that it's not going to touch it at all. Now, 2 real solutions will also apply when we go ahead and factor, but not everything that has a real solution is factorable, which is why we have a quadratic formula.